Hello friends and welcome back. So now in this session we will learn why Terraform. So we have a multiple options are available in the market, okay? But why we opt for the Terraform? So far we have discussed in detail about what exactly is the Terraform, why we use the Terraform, what are the benefits of a Terraform. So why Terraform is something you can consider as a benefit of Terraform, what we have discussed so far. Okay, so I know that some of the contents are getting repeated in the couple of sessions. Okay, that is just because to give you a good understanding of the Terraform. So before we jump into the execution in the actual architecture of the Terraform, which will be starting from the next session, okay, before that you should get a complete understanding of Terraform in your mind. What exactly is the Terraform? What are the different benefits of Terraform? Why we use it? Where we use it? Okay, so that's the some contents I am getting repeated in the few of the sessions. So why Terraform? So we know that there are many infrastructure as a code tools are available, but Terraform has become one of the most popular tool of infrastructure automation. It helps organizations provision and manage infrastructure efficiently using code. So this is one of the major benefit, right? So we are maintaining the infrastructure as a code, and when we maintain it as a code, then we get all the benefits that we get when we are maintaining a certain set of code. Okay, that means our application code. So like we maintain a centralized repository where we have the different versioning of the code. Similarly, if we are maintaining our infrastructure again as a code, then we'll get the same set of benefit, right? And it is widely used in modern cloud environment due to flexibility and multi-cloud applications. So let us talk about each and every benefit one by one. So I will cover this benefit in a very short session and with a very basic explanation. The very first thing, cloud agnostic design. So what is the meaning of cloud agnostic? That means the Terraform is not tied up to a particular service, cloud service provider. Okay, we know that we have a multiple cloud service providers in the market, right? We have AWS, sorry, right? We have AWS, we have Azure, we have IBM Cloud, we have Google Cloud, we have Oracle Cloud. Okay, so this particular Terraform is not tied up to a particular cloud service provider. You can use it for any of the cloud service providers. So many tools are there in the market. They are specifically the cloud agnostic. Okay, that means they are tied up to a particular. They may be supporting only AWS or they may be supporting only Azure, but Terraform is a tool, okay, which support multiple cloud service providers. Okay, and it support the multiple cloud. What does it mean? So as I said, it is the your Terraform support the multiple cloud service providers, right? And if you have a requirement where in your organization you have a certain set of resources which is exist in the AWS, some resources exist configured in the Azure, or maybe some resources are configured with some other cloud service provider. You want to maintain, you want to do certain set of operations in a single go, okay, with a single execution. So you can use Terraform where you can do a lot of automations, and with a single click you can do same set of or different set of operations which can be executed together in the multiple cloud service platforms. Okay, so in that case your organization has to use only a single tool, right? So as I said, there are multiple tools are available in the market which support only some specific cloud service providers. So if you have, if your organization is using the services from the multiple cloud service providers, you don't need to go with the different tools. You only go with the Terraform tool, and with the help of Terraform tool, you can manage all the resources that is there in the multiple cloud service providers. Large provider ecosystem. So that means it has a large set of plugins. Now, what is the meaning of plugins? So what we have discussed so far, your Terraform support the multiple cloud service providers, right? So to make the connectivity with the multiple cloud service providers, your Terraform need the plugins. It needs the plugins, which is also referred as the connector, right? Because your Terraform is going to connect to a specific cloud service provider. So that means it needs a certain kind of a plugin or a connector to connect with that particular service provider for execution of our code to configure the resources. right? So that means for that we need a certain set of plugins. And this Terraform support a large number of providers, right? So that means it has a rich library of the multiple plugins, and that plugins allow your Terraform to connect to any of the cloud service providers. Okay. Declarative infrastructure. So what we have learned in the previous session as well, we have an imperative and declarative infrastructure, and your Terraform is called the declarative infrastructure. That means you don't need to define step-by-step instructions. You just need to define your goal, what exactly you need. I need an up and running virtual machines. Okay, so you can define these set of instructions in the Terraform. Okay, instead of writing step-by-step information to create a server, we can simply declare what type of server we want or the configuration of the server you want. Terraform automatically determine how to create or update the infrastructure. That means our infrastructure as a code or Terraform use a declarative infrastructure. State management. This is one of the important property of your Terraform, state management. Okay, so we will have a detailed session on this once we will start configuring the or learning the different set of configuration files in the Terraform. Okay, so there we will learn about the state management, because when we run the Terraforms for any of the software provisionings or the hardware provisioning, it creates some state file. Okay, this state file track the complete infrastructure it is going to manage, and what are the benefit of that. So this state file understand what resources already exist, what changes are required, what need to be created, modified or removed. So that means whenever we run the Terraform to create any of the resources, it automatically create a state file. Now for example, I ran my Terraform to create one virtual machine which contain one web server. So once I run the Terraform script, okay, it will create a state file, and this state file will contain the information about the infrastructure that has been created during the execution. Okay, so now this state file has the information about what exactly exists in your infrastructure. You have a virtual machine which contain a web server. This is the information about the existing resources. Now suppose that you are going to change some resources in your machine. Here you have a web server, okay, and you are going to configure or update some parameter, or maybe you are going to install one more web server. Okay, so when you run the Terraform files again with the modifications, then your Terraform easily understand what are the changes required based on the configuration files. It is not going to touch any of the existing environment. If even by mistakenly you are trying to modify any of the parameters there, okay, and then it is not going to touch your existing infrastructure unless and until you are intentionally going to modify that one. Okay, so that means it contains the information or the resources that need to be created, modified or removed. So every information is maintained in this state file, and this state file has a great importance in the Terraform. And then modular architecture. So what is the meaning of modular architecture? It is just like object oriented programming. OOPS concept. Okay, define once, use at multiple places, just like the functions in the programs. So what we do, if we have a certain kind of a code that is going to be repeated in our program at multiple places, we define the function and simply we call the function. We don't write the same code again and again, right? So that means we are going with the concept of OOPS concept, right? Define once, use multiple places. Similarly, when we maintain the infrastructure as a code with the help of Terraform, so that means what we are doing, we are getting the benefit of reusability, better organization of code, and easier maintenance. That means suppose you have configured or you have defined some Terraform files where you are going to create one VPC. Inside the VPC, you are going to create some servers, and then you are going to configure the load balancer, right? So this automation Terraform scripts are there with you. Now suppose that again you have some requirement where you want to configure some VPC, some group of servers, some load balancers. So you can utilize same set of configuration files that you have already built in your environment. You don't need to define the code. You don't need to define the script again and again. You can utilize the same script. The only thing is that you need to provide the proper inputs. For example, suppose that you want to create a VPC with the name of VPC1. You want to create 4 servers. You want to create a load balancer LB1. So you need to provide the corresponding input, and based on that input, your resources will be created. That means it has a modular architecture. So once the code is designed, scripts are created, you can use the same scripts across the multiple environments without writing the code again and again. So what are the key takeaways that we have learned from this particular session? Your Terraform is a multi-cloud infrastructure management tool, cloud independent, right? Doesn't have any dependency on a particular cloud service provider. It supports many providers just because of the multiple plugins. It uses a declarative infrastructure, reliable state management, and reusable infrastructure.